the laws of motion. Learning about force and motion. Throw a ball in upward direction. Bring a chair towards yourself. Move the wooden box in the room to one corner. Pick up a bucket full of water. Collect scattered pins by using a magnet. In all the above cases, is it possible that the motion of an object starts spontaneously? It is not possible that the motion of an object starts spontaneously. What did you do to start the motion? We pushed or pulled an object to start the motion. What is the cause of motion? Force is the cause of motion. Force and motion. When there is a change in the position of an object with respect to its surrounding, it is said to be in motion. We can bring a body in motion and can also stop a moving body. Motion does not start or stop spontaneously. We cannot stop a moving vehicle without applying brakes. Even a rolling object stops after rolling some distance as resistance offered by the ground. Force is required to put a stationary body in motion or to stop a moving body. Force also can be used to change the velocity of an object or direction of motion. The force also can change the shape of a body. When we apply a force on a rubber band, spring, rubber roll, the change in shape can be observed. When we push, pull or hit an object, we make a force to act on them, due to which we can bring the object in motion or can stop it. Force is an interaction between two objects. Force is not visible, but we can see the effects of force. When a book is kept on a table, the table exerts an upward force on it, but it is not visible. All that you observe is that book remaining stationary. When a ball is hit on a ground, it bounces in upward direction. It is the visible effect of force. Force is a physical quantity that changes or tends to change the state of rest or uniform motion of a body in a straight line. The force acts along a line in a perpendicular direction and has some magnitude. So to describe force, we must specify both its magnitude as well as direction along which the force is acting. Activity. Take a wooden block, tie two strings A and B to the two opposite faces. Place it on a table. Now, apply a force to pull the string A to the right. What do you observe? The block moves to the right if the force is large enough. Now, apply a force to pull the string B to the left. Does it agree with the previous observation? Now, the block moves to the left if the force is large enough. In the previous case also, the block moved in the direction of the applied force. What will happen if you apply equal in magnitude forces opposite in direction on both sides of the block? The block will not move if we apply equal in magnitude forces opposite in direction on both sides of the block. When two forces acting on a body are equal in magnitude and opposite in direction, we get the net force acting on a body equal to 0. The two forces are balanced, so the body remains at rest. In the game of tug of war, when forces acting on both sides are equal, they balanced. Similarly, when an object is kept on the ground, it remains at rest under the action of weight of object and force of gravity acting on it. Balanced forces do not change the state of rest or the motion of an object. It moves with uniform velocity when forces acting on the object are balanced and there is no net external force on it. but an unbalanced force acting on an object brings it in motion. Due to the unbalanced force, there is a change in the speed of an object or a change in the direction of motion. An unbalanced force is required to accelerate the motion of an object. So long as the unbalanced force is applied to a body, there is a continuous change in its speed. What will happen if the force is removed completely when the object acquires a certain speed? Activity. Arrange the carom coins at the center of the carom board, one on top of the other. Hit the bottom coin with a fast-moving striker. What do you observe? Bottom coin moves forward and the another coin moves downward or spread on the board. Switch off a rotating electrical fan. What do you observe? When a rotating fan is switched off, it continues to rotate for some time due to internal friction and with friction with air. The fan stops rotating after some time. A body resists change in its state of rest or of uniform motion. You may have experienced this situation in daily life many times. When we travel by a bus and the bus starts moving suddenly from a rest position, we get a jerk. When the bus is at rest, our body is also at rest inside the bus. As the bus is put in motion, the portion of our body which is in contact with the bus acquires velocity. But the upper part of the body tries to remain at rest, so we fall back. The exact opposite situation occurs when a moving vehicle suddenly stops by application of brakes. In this case, our body falls forward because when the vehicle is in motion, our body inside it is also in the motion along with it. When the vehicle stops, the lower portion of our body, which is in contact with the vehicle, also comes to rest. But the upper portion tries to retain the state of motion and falls forward. The tendency of a body to resist changes in a state of rest or state of motion is called inertia. No external force is acting on an object at rest, it will continue to remain rest while a moving object continues to be in motion with the same velocity. Types of inertia. Inertia at rest. The inherited property of a body by virtue of which it cannot change its position of rest is called inertia of rest. A fruit falls down from a tree when the branches is shaken. This is because the branches is set into motion but the fruits stayed in the state of rest. Inertia of motion. The inherent property of a body by virtue of which it cannot change its state of motion is called inertia of motion. For example, when a rotating fan is switched off, it continues to rotate. Inertia of direction. An inherent property of a body by virtue of which it cannot change its direction of motion is called inertia of direction. For example, while sharpening a knife, sparks fly off tangentially from a grinding stone. Newton's first law of motion. Activity. Put a smooth cardboard on a horizontal table. Keep a heavy book on it. Pull the cardboard suddenly in a horizontal direction. What do you observe? Cardboard comes out, but the book does not move in the direction of motion of the cardboard. Every inanimate body continues in its state of rest or of uniform motion in a straight line unless an external unbalanced force acts on it. This is known as Newton's first law of motion. Newton's first law explains inertia, that is, inability of a body to change the state of motion by itself. It also explains force which changes or tends to change the state of rest or of uniform motion of the body in a straight line. All the examples of inertia are examples of Newton's first law of motion. When there is a change in the position of an object with respect to its surrounding, it is said to be in motion. Force is required to put a stationary body in motion or to stop a moving body. Force also can be used to change the velocity of an object or direction of motion. The force also can change the shape of a body. The tendency of a body to resist change in a state of rest or state of motion is called inertia. Every inanimate body continues in its state of rest or of uniform motion in a straight line unless an external unbalanced force acts on it. This is known as Newton's first law of motion. That is all in this topic. Let us learn Newton's second law and third law of motion in our next topic. Till then, keep learning.